Alright, CNT125, Chapter 12, WANs. We're looking at Layer 1 technologies. We're looking at cable broadband. So cable broadband or cable modem access. This is based on your cable coaxial TV wiring used for cable TV for many years. And along came the need to, hey, can we send data across there? So, we were sending multiple television signals to houses. So, hey, is there a way we can, add a channel for data? And I'm using air quotes around that, if you will. So along came a standard specified by Cable Labs. They basically came up with a way to do this, and the specifications called for the DOCSIS standards, Data over Cable Service Interface Specifications. And there's a bunch of different those standards. Typically offered at asymmetric speeds, 50, 60, 70 meg download, and 5, 6, 7 meg upload kind of thing. Newest DOCSIS standard 3.1 allows for full duplex or symmetric speeds up to 10 gig in both directions, so that bandwidth has climbed up over the years, giving more capability. Many of the cable companies employ a fiber cabling infrastructure to get the signal to people's houses. So you end up with a hybrid fiber coaxial system. What ends up happening is fiber gets used from the company's head end the whole way out to maybe a box in your neighborhood. From the box in your neighborhood to your house, many times is still coax cable into the modem in your house kind of thing. So your structure ends up looking like so. The cable head end, or the cable company's central office, if you have to connect it back to PSTN terms, your cable head end uses a fiber infrastructure the whole way out to a box that's in maybe your neighborhood. Then they might use coax cable from there into individual houses on your street, if you will. If you're thinking of maybe a development, this might be a node for a cul-de-sac, and then from that node are coax lines to all the houses on the cul-de-sac kind of thing, if you have to kind of visualize this infrastructure. That coax comes into your house into a cable modem. The cable modem is there to basically pull that data stream off, or I should say take the data stream from your computer and put it into a channel to go back across the system to your cable company provider. And again, your standards, your DOCSIS standards for these cable modems. And here those are for you: 1, 2, 3, 3.1, etc., giving you a ballpark idea of throughputs for these guys. Your cable modem operates at layer 1 and layer 2. It does not deal with higher layer protocols. As we said before, most of your layer 3 and above is all the same from LAN to WAN. So this is a layer 1, layer 2 signaling, and it really connects to the customer's PC, maybe a NIC cable, that sort of thing, or wireless interface, the connection between. So let's start taking a look. This is an old school cable modem, but you see it's basically a coax line from the provider and a data port and network interface for the computer. So in the original sense, you had a coax line coming from the provider into the modem, and then you had a network patch cable connecting the NIC on the modem to your PC. And that was kind of the straight up connection that most people used for years. And if you start expanding that a little bit, you can see coming out of the cable outlet, you might have a splitter, one line going to the TV, one line going to the modem, and then to the PC kind of thing. Again, that was very common. Along comes the need to add a few more nodes in your house. So the structure still stays fairly similar. Your DSL or cable connection, so they're putting DSL here, same kind of idea, comes into the modem. Out of the modem, it connects into a router. The router now has the capability with some switch ports to plug in a couple nodes, and because it's a network in a box, if you remember me talking about that way back from CNT120, it also has an access point built in, so now I have the capability to plug in a couple nodes as well as wirelessly connect a couple nodes to this router. So most of our structures now look like this, whether you have cable or DSL kind of thing, for that matter even FiOS, your structure looks very much the same. Whatever box they're giving you, whatever type of modem they're giving you, most of us plug that into a router. network in a box. And now I have capability for a couple nodes to plug in, as well as wirelessly a couple nodes to connect to. And here would be samples of, in this case, this is a Verizon Fios router, but it's the same idea. Here's the coax connection coming in, a couple switch ports here for a couple nodes. Also have wireless for wireless nodes in my house. Again, showing maybe a little bit closer to home for you guys. Coax line coming in into a splitter. One of the connections goes to your set-top box for your television. The other goes right into your router, your cable router. And then this actually has in, as you see right here, the modem and router all combined into one box. And then I can plug my desktop PC in, and then there's wireless to connect my wireless nodes too. That should start looking like a lot of our connections in our houses now. Just a reminder that with our cable TV, our coax, you actually have a couple of signals multiplexed on here. Your video signal, your cable data, your telephone, all multiplexed across this cable going back to your broadband provider. Just as a little kind of reminder on the signaling that's going on there. Like DSL, cable broadband provides dedicated, always-up connection. You don't have to dial in or anything like that. It's always there. Unlike DSL, cable broadband requires many subscribers to share the local line. So over the years, there's been a lot of people asking questions and frustrated. You look at the agreement from your cable service provider and it says up to 20 meg, and you might only get 10. Well, first part there is the contract says up to, so they're not guaranteeing 20. So if you're getting 10, you're getting the up to 20 meg. Secondly, because of the structure, if I zoom back here, let me zoom back here real quick. If you look at the structure here, if you look at this really, this almost looks like a bus network. It kind of is. So if I have a lot of people on this bus network, a lot of people are sharing, the bandwidth is going to get distributed a little bit. So with this structure, the more people using it, the more the bandwidth is getting shared. Now, over the years, they've done a lot to help improve that, but reality, the structure is thus. So there have been worries and cases over the years of people being disgruntled at the bandwidth they're getting. With the structure as it is, it's going to be shared a little bit. So it's going to fluctuate depending on the number of users and number of people in the area using it at a given point in time. That's just the way that structure is. All right, we'll come back in the next one, talk Metro Ethernet.